Hi everyone, this is Dr. Ravinder Gandasiri, Assistant Professor in Physics, Department of Freshman Engineering, St. Martin Engineering College. Today I am going to give talk on Introduction to Nanoscience and Nanotechnology. Here, what is nanoscience and what is nanotechnology? Nanotechnology is a more advantage in society to their applications. Here, technologically developed countries are most in nanotechnology. Here, the nanotechnology is immense application in society like medicines and drug delivery, and also food safety devices and storage devices. Here, nanoscience. What is the nanoscience? What is the nanotechnology? Nanoscience is study of matter. Nanoscience is study of matter at nanoscale, which is between 1 nanometer to 100 nanometer. 1 nanometer to 100 nanometer. Nanoscience is study of matter at nanoscale, which is between 1 nanometer to 100 nanometer. Here, what is nanotechnology? Nanotechnology. Nanotechnology is matter of manipulated matters and their design and application at nanoscale range. These devices, at least this material's size in one dimension, at least to below 100 nanometers. First of all, we take what is nano. Nano equal to 10 to the power of minus 9. 1 nanometer equal to 10 to the power of minus 9 meters. This is the nanometer. Here the word prefix nano comes from Greek word that is nanos. Prefix nano words come from Greek word nanos. Nanos means rough. That means a small pieces. Nano means a small pieces. Here, nanomaterials depends on their size. Materials depends on their size. The size is between at least one dimension below 100 nanometers. At least one dimension is below 100 nanometers. These nanomaterials is completely different their properties with bulk materials. See, what is the difference between bulk and nanomaterials? First one is size and scale. First one is size and scale. Second one is surface area. Surface area to volume ratio. Second property is difference is surface area to volume ratio. Third one is properties. Fourth one is quantum effect. Fourth one is quantum effect. These are the difference between nanomaterials to their bulk. Here, now what is size and scale? Here, the material's properties depends on the material size. That material size in 100 below 100 nanometers. And next one is surface area. Surface area to volume ratio. Second one is surface area to volume ratio. What is surface area to volume ratio? Nanomaterials have high surface area compared with their bulk materials. Here we can see the example of sphere. This is sphere. This is center of the sphere. This is radius of the sphere. Now the surface area of sphere equal to 4 pi r square. We know the surface area of sphere equal to 4 pi r square. Then volume equal to 4 by 3 pi r cube. Volume equal to 4 by 3 pi r cube. Surface area equal to 4 pi r square. Volume equal to 4 by 3 pi r cube. Then this ratio 4 get cancelled, pi get cancelled, and pi r square r 3. Now the ratio is 3 by r. This is the sphere surface area volume ratio. See this ratio, this r is inversely proportional to the ratio. Here r means the radius of the sphere is inversely proportional to the radius. That means small size of sphere have high surface area to volume ratio, and large size of sphere have low surface area volume ratio, because of the radius is indirectly proportional to the ratio. High surface area, what is the uses of the high surface area? Because of the molecule more interact with chemical reaction compared to their volume ratios. This is the beauty of the nanostructure. Suppose we take the 1 cubic centimeter, break down into small pieces, in nano level size pieces, that pieces arranged into one by one, that is fulfilling one football stadium. that is the beauty of the sphere. Another example we take cubic. Take cubic. Here we assume this length is 1 centimeter, width is 1 centimeter, and height is 1 centimeter. Now what is this surface area? This surface area is, we have the crystal is, this cube is 6 planes. One plane surface area equal to 1 into 1 equal to 1 centimeter square. Total surface area equal to 6 planes, 6 centimeter square. Now this cubic volume equal to 1 into 1 into 1, this is equal to 1 centimeter cube. That means 1 centimeter cube. See this ratio. This sphere ratio is 1 centimeter length, 1 centimeter width, 1 centimeter height. Cubic ratio is 6:1. See, take another sphere, bigger size sphere, large size sphere. Suppose you assume this sphere is 2 centimeter length, 2 centimeter width, 2 centimeter height. See, what is the surface area of this cubic? This cubic surface area equal to 2 into 2, 4, one plane, 4 into 6 equal to 24 centimeter square is this cubic surface area. This cube volume equal to 2 into 2 equal to 8 centimeter cube. So the surface area of to volume ratio equal to 24 is to 8. That means 3 is to 1. See, small cubic small volume cubic is surface area volume ratio equal to 6 is to 1. This surface area volume ratio equal to 3 is to 1. So compared to these two cubes, this surface area volume ratio is very high comparably. Then another difference is properties. Properties. Which properties? Optical properties. Optical properties. Second one is electrical properties. Third one is mechanical property. Fourth one is magnetic property. Here see the optical property, magnetic property. These are the optical properties, electrical properties, mechanical properties, and magnetic properties. These are the four properties. These four properties are also depends on their size. These four properties depends on their size. First of all, optical property. Optical properties. Here, you know the optical properties, three types of optical properties: absorption and transmission another one is reflection. These are the another one is emission also. Emission, absorption, transmission, reflection, and emission. These are the optical properties. Another one is electrical properties. Electrical properties. What is the electrical properties? The electrical properties are mainly electrical conductivity, and electrical resistivity. These properties also depends on the nanomaterials. Already we know nanomaterial size in at least one dimensional below 100 nanometers in size. These materials gives radically changed their properties. That properties, optical property, electrical property, magnetic property, and mechanical properties. What is the mechanical properties? Mechanical strength, yield, elasticity. These are the bending, stretching. These are the mechanical properties. And magnetic properties are the storage devices is the storage power in the is magnetic property. Another one is quantum effect. Quantum effect. Another one is quantum effect. Quantum effect depends on quantum size. Classical mechanics did not say about the quantum effect, said about, but quantum effect is depends on quantum size. Even though we know the quantum size and quantum phase, that is one is quantum dots. Quantum dots. Second one is quantum wire. Quantum wire, quantum tubes, quantum nanotubes. These are the quantum errors. Third one is quantum wells or thin films. These quantum materials, quantum shapes are is mainly depends on the materials properties. Materials properties depends on this. Coming to now, let us see PPT. Here, see here this PPT. Nanotechnology is more depends on the their size are already we discuss this shape and size. Already we discussed this shape and size. Now I will show the quantum size and the quantum shapes. What is the effect on the quantum size and quantum shape? See here, the what is nanoscience? Already we discussed the nanoscience is the study of object and phenomena, very small scale, roughly 1 to 100 nanometers. Already we discussed about this. Now the 10 hydrogen atoms lined up measure about 1 nanometer. Here the nanoscience involve the emerging interdisciplinary science, that is the physics, chemistry, biology, engineering, and material science and computer science. Now, how big is a nanometer? You know our human cell size is in micrometers. Here, see our human hair size in approximately 50,000 nanometers to 1 lakh nanometers. The human air width is approximately 50,000 nanometers to 1 lakh nanometer. Already we discussed the 10 hydrogen atoms laid side by side, that length is 1 nanometer. Here the DNA width is 2.5 nanometers. Our human red blood cell width is 7,000 nanometers. See how big is nanometer? Just you imagine, that is very small pieces. Another one is, see the what is nanotechnology. The word nano is adopted in International System of Units at 1984. 54. The International System of Units adopts the units of the nanotechnology. Nano is 1954. Then the nanotechnology what is first introduced in Tokyo Engineering Conference at 1974. See, what is nanotechnology? The technology is the manipulate of matter to create new materials and devices with at least one dimension sized from 1 to 100 nanometer. Already we discussed this. At this scale, matter exhibits unique physical and chemical biological properties. Here, this is the quantum dot, this is the quantum wire, this is quantum well, this is bulk material. Here, these quantum dot materials, all three dimensions is below 100 nanometers. This quantum wire, two dimensions have below 100 nanometers. Here, thin films, one dimensions have below 100 nanometers. This is bulk materials. All three dimensions have above 100 nanometers. See the difference between the bulk and nanomaterial. Already we explained that size and scale is different between their bulk and nano. Surface area to volume ratio is completely different, their bulk and nano. And their properties already discussed the complete difference with bulk and nano. And quantum effect also all the difference in bulk and nano. The properties all depends on their size in nanomaterial size and shape. Here see, we know the silver metal color. What is it? Silver color generally. But see here, silver nanoparticles at 10 nano meter size particles have different colors. 30 nanometers particles have different colors. See the variation of these colors. And 60 nanometers particles have different colors, and 80 and 100 nanometers particles have different colors. That means the absorption of the wavelength is different based on the particle size. And there are other properties, electrical property, magnetic property also different with the their based on their material size. See this chameleon. Chameleon skin have different colors because of the chameleon skin have nanoparticles cells. Our human cells is in micro levels, but chameleon skin cells in nano levels, and they have different grain sizes. Different grain sizes, skin color is different. This skin is adjustable. Chameleon skin is adjustable in their cell size, either compress or flex. Based on cell size, the color is changed. Another one part is types of materials, nanomaterials, nano powders, and thin films are part of nanotechnology. Nanometals can be found in nature, that is the virus and blades. Generally, virus size is 20 to 25 nanometer. Already we said the red blood size is in 7,000 nanometers. This figure shows about the artificially created nanomaterials. This is graphene. The rolled graphene is this carbon nanotubes. This is graphite. This is carbon nanotubes, multivalent carbon nanotubes. See, this is the nano powder. This is the thin film. Here, the cadmium sulfate nanoparticles color shows the at 2 nanometer have different color, materials color. That means these properties are different. At 6 nanometers, it have different colors. See, this is the thin film. What is the thin film? Thin film is a layer on substrate. Its thickness is below 100 nanometers. That material is called thin film. Some types thin films have 1 nanometer to below 1 micro nanometers. Here, the thin film property is completely different with their bulk material. Because of the thin film surface area is high comparably their bulk material, and their properties also completely different. See, these thin films, these 4 thin films are vanadium pentoxide thin films. Here, annealing temperature thin films, these 4 thin films. At 30 degrees annealing temperature and 100 degrees annealing temperature, at 200 degrees annealing temperature, at 300 degrees annealing temperature. At 30 degrees temperature, this film have different color. At 300 degrees temperature, this film have different color. See that this is the application of nanotechnology. One of the application is microelectronic devices and drug delivery system, biosensors, and energy storage and power generations, aerospace and water filter, and textile also, and protective coatings, optical coatings, sensor, gas sensors, devices are made by the nanotechnology. See, this is the self-cleaning. This video shows the self-cleaning class. Here, see this video. See this video. Once I see this video, even if water throw on glass, the shirt not get wet because of this shirt coated with the wax coated materials. In nature also, lotus leaf have wax coated bumps. That's why the materials also, the lotus leaf also have super hydrophobic property. Here, the shirt also have super hydrophobic property. See another video. See this video. This is the vanadium pentoxide nanoparticle synthesis. Here, this is the magnetic stirrer. This is solvent synthesis. In starting point, in starting stage, the materials have yellow color. The solution have yellow color, but after exothermic reaction, the particle size is change. Then see here the solution colors also changed after exothermic reaction. This is the beauty of the nanoparticles. This is the solvent synthesis. Here the solution is precursor solution is hydrogen peroxide and vanadium pentoxide materials take the starting materials. See the color is changed yellow to orange color. This is the beauty of the nanoscience. Now let us going to the preparation conditions and preparation methods, different preparation conditions and different preparation methods. See what is the different condition, preparation condition? See here properties depends on different parameters like size and shape and thickness, surface morphology, crystal structure, grain size, handling temperature, deposition and preparation methods, and nature of substrate, nature of material, dopant and precursor solutions. These are depends on the properties. Here these growth conditions, see the crystal properties and chemical properties, electrical properties and mechanical properties and optical properties depends on the growth conditions. Materials properties and material application depends on this parameter. If particle size is high, the band gap is low. The material band gap is low. The thickness of the material also depends on their application for properties. Another one part is surface morphology. Surface morphology role is important role in thin films because of the surface reaction electrical properties for devices. The surface morphology is most important. This surface morphology depends on the growth condition. Suppose with handling temperature is high or low, the change the surface morphology and precursor solution also gray and nature of the substrate. These are the parameters are depends. Another is synthesis method for nanoparticles. This we have two type of synthesis: top down approaches, bottom up approaches. Here top down approaches bulk material converted into nanoparticle. Here bottom approaches atoms and molecule prepare to nanoparticles. See the thin film deposition techniques. Here we have two types: physical techniques and chemical techniques. Physical techniques: vacuum evaporation, sputtering, gas phases, liquid phases. In liquid phases we have spin coating, spray pyrolysis, dip coating. Generally these are the low cost and effective preparation methods. See, these are the SEM images of the thin films, vanadium pentoxide thin films. Here this is the SEM and XRD images of the vanadium pentoxide thin films grown the silicon substrate at different precursor concentration. different low precursor concentration materials have low grain size, low particle, small particle size. High precursor concentration is molecules surface grains is high. This is the XRD. See, this is the AFM images. These are the see this nanoparticle application. Once check microelectronic application and photonic devices. These devices and gas sensor, these applications are mostly useful to the society. Technologically developed countries in forefront in nanotechnology. Nanotechnology is in modern research is nanotechnology is forefront. See, giving to conclusion, then nanotechnology holds immense potential across various sectors, offering groundbreaking innovations. However, challenges like safety, scalability, and ethical concern and address it to harness to benefits of responsibility. Here, these are the deep introduction of to nanoscience and nanotechnology. Thank you.